Hi everyone, welcome to my introduction to sound design and the audio gear needed to deliver said design. I'm Scott Parker from Stage Seminars, and I've been in theater for a long time. What is our job as sound designers? Everyone from the designer on down is involved with creating the environment in which the event takes place. The designer designs, the crew executes, and together we create a symbiotic relationship to get the show to the audience. And our job is to support the work of the production. So let's talk about what a design is. Let's look at this next slide. And I want to be quiet for a moment and let you listen. We want to transport our audience to where we want them to think they're sitting. What does this sound like? Well, this image doesn't work at all, does it? Does this sound like this image? We're presenting a visual image on stage between the other designers, and sound designers need to also bring that image to light. What weight should we be giving to the soundscape? Let's change the sound for a second. What do we hear now? When I look at this picture, it reminds me of when I used to teach scuba diving, and I would take divers down to Caribbean locations that were very similar to this. And being in these huts over the water, I would hear water lapping underneath the hut, just like we hear in the sound design that I'm playing now. This probably works better, doesn't it? Now, as we move forward, we're going to discuss how we have different kinds of sound designers. Now, I'm primarily the first type here. I'm a sound designer for musicals. With many crossovers and many exceptions, sound designers are often clumped into these two camps. Sound designers for musicals might be wrangling dozens of microphones on performers and a completely separate set of microphones for the orchestra. In addition to that, they will have several sounds, such as effects, to be delivered via recorded playback devices. Could be doorbells, it could be fire trucks, things the orchestra doesn't play. Sound designers for straight plays, on the other hand, are many times also composers, as they may supply original music to underscore the dramatic piece or emphasize, comedy moments. Those that are not composers will often use their vast knowledge of current recorded music or even past recorded music to add a tone for the show in their underscoring. And of course, we're all going to be dealing with those sound effects. This guy, Jack Foley, he invented a whole nother range of sound design back in the 1930s. Live sound created by someone other than the performers on stage is often called Foley. Named after Jack Foley, the Foley artist creates live sound effects that mimic the sounds one would hear during the performance. This could be in radio, television, movies, or in live theater. One of the most well-known theatrical uses of the Foley artist is for the play Our Town, because sometimes we'll put the Foley artist on stage. After all, it's a play about a play. You have the stage manager narrating. Though I didn't see it, the Broadway production of SpongeBob SquarePants used a percussionist to create all those animation punctuation sounds. And this percussionist performer was on stage. Recorded sound effects and or backing tracks are usually delivered via the sound system by the front-of-house audio engineer. I use the term engineer loosely, as we're not actually licensed engineers. But the front-of-house mixing operator, that person that has their fingers on the board the entire time, is quite busy. Now, delivering the recorded sound might be coming from tape decks, CDs, mini discs, a record, or currently we're using computers. Now, for both theater and film, it starts with a performer. And it goes, you know, the input is they're talking, and like this guy with the megaphone, you're talking into one end. We usually talk into microphones. So the microphone is the input, and then it's going to go through a processor of various types. It could be just the mixing board. It could be EQs and other things. And then it's going to go through an output and ultimately to the speakers. So here's an illustration of some inputs. We've got several microphones and we have a piano keyboard as an example. And they're all going to go into a mixer. Now the mixer is going to combine it and change levels. And then it's going to send it out to the amplifiers or to a powered speaker. We'll discuss that momentarily. And the amplifier is going to send it out to the house speaker system. Most of the time, house speaker systems do need amplifiers, as they're considered passive speaker boxes. Let's look at the microphones first as our main input source. First, we have something for wide close-up work. This one is one of my favorites. It's a PCC-160 Floor mic by Crown. You put this, a lot of people put it at the edge of the stage and picks up sound from the middle stage on up to the edge. For people that are further away, using a shotgun microphone comes in handy. We can hang this from above and point it down over the heads of the people that are in front and pick up people who are upstage. We're going to do some layouts in future classes of looking at how we lay out our systems on paper. The last one is the infamous SM58 microphone from Shure. It's a personal handheld mic. You would hold it up close. This is similar to it, but it's by a different company. So you would hold it up here. A lot of rock and roll singers, as you know, will use it. It's on all the shows for concerts and such, but we don't use it a whole lot on stage for our use, though there are certain examples. What we use most often for musicals is a wireless belt pack with a small microphone that can go over the ear or in the hairline. The black one in this picture would go down in the hairline, and you can get these in whatever color you need in order to blend in with the performer. The lighter color one you can also color with a set of pens that you can get to match people's skin tones. What I try to avoid is having people tape the microphone here on their cheek. It gets really distracting. For me, if I needed to get the mic really close, I'd probably put it in the beard and have it just stick out a little bit, or up here to the side. You know, up here you're going to see it because I don't have a lot there. But over here you could hide it. Microphone placement can vary depending on who the performer is. Different microphones will pick up different people in different ways, and that's something that a sound designer, as they gain more experience, will learn along the way. Here's a musical instrument. It's just a piano keyboard, and you could plug this directly into the mixer and take that signal in and mix it with the other stuff and then send it out to the speakers. Some musical instruments, though, it's better to mic them separately. For example, this guitar amp. I swiped this image from Sweetwater, thank you to them, and it's a guitar amp with a speaker in it, and it has a microphone that's pointing towards the speaker cone. In future classes here on stage seminars, we're going to examine where on the speaker cone to put the mic. But if you have this equipment, you should play with it. Move the mic around and point it straight at the speaker cone, or point it from an off angle at the speaker cone, or point it to the side of the speaker cone. They'll all sound different. There's a lot of YouTube videos. We're going to watch a couple of them together at some point and unpack what they're talking about. Other inputs we're using for sound playback, we're all using computers nowadays. Are you using computers? I'm going to take a poll momentarily, but here's an old picture of a computer plus a picture of an iPad with a computer program to do playback. We can use iPods, iPads, and so on, and even MP3 players. Okay, the next slide has my results from Facebook. I took a poll on Facebook. Now, these two programs, one is QLab and one is SFX. QLab works on the Mac and SFX works on Windows. And our poll results here show us that QLab has 197 votes, while SFX has 8. I've used both, and QLab is much more modern, I have to say, and again, works on a Mac. These other three packages that are between QLab and SFX I have not used. But we're going to explore them, and I'm going to find people that can offer us some training so we can learn how well they work. Do you have tutorials for any of these that you like? Send them along, and we'll watch them together. Other playback devices. Now we're going back a ways. Does anybody have a cassette deck or a CD player? I'm sure several high school and middle school booths have these still installed. And if they work, they work. It's like lighting devices. You know, people ask me, what's your favorite lighting instrument? I say, well, A, the one that'll do the job. And B, if it spits out light, I'll figure out how to use it. If it spits out sound, we can figure out how to use it. Now, tape players are a little bit noisier nowadays compared to CDs and certainly compared to digital devices, because there's an underlying noise or a hiss that can be on the tape. But you can still process that anyway. The mixing board here we have is this is a Mackie board. It's one that I happen to have here that I can use to demonstrate some stuff. We have our inputs up here. This is where the mics come in. Okay, and that microphone signal travels through the wires. And it goes down through the gain adjustment, which adjusts how much sensitivity the mixer is giving or assigning to the microphone. It's another avenue of gain control and the gain process, and balancing for gain is an in-depth topic, and we'll be covering that again another time. But suffice it to say, you see that this one is pointing off to the right a little bit. This one's all the way down at full to the right. This one's almost in the middle, and so on. And the other ones are just sort of there because I'm not using them. But these tell us how sensitive the microphone is going to be. Further down the track, so we adjust the volume or the gain, not the volume, it's different, the gain, and it sends it down to, we're going to go past the pan, it sends it down to this slot here where this slider sits. So this is at 0 right now. This one is at the U, which means unity, which means that we're not giving any extra signal, but we're not holding any back. The signal then goes back up through the mute button. If we press the mute button, it cuts it off. Doesn't matter where the slider is, it cuts it off. It then goes up through the left-right control. So if you turn this dial to the left, it's going to pan left, and to the right, pan left, right, and so on. It's then going to go up through some other processing, which I will show you, and over to the output, so that it then goes to the amplifiers, and that takes us through the speakers, and the speakers look something like that, and then all the sound comes out, and we have sound waves, and we hear it. So that is the basic path through this mixer. I'm getting the audio from the mic input up here, down through the slider, okay, and out through the master sliders, which are hidden over here, not in view. But there's two more sliders for left and right. Okay. So that's the mixer. After that, we have some processes to deal with. We're going to process our signal and maybe give it some EQ or some equalization. We might add some compression or delay. We may also deal with, the signal path. All of them have the signal path, but EQ, compression, and delay are used fairly often. We're going to talk about EQ today. The sound goes through the system via the microphone and comes out the speakers at the other end. And we're going to process it through the entire process time, and that's called the signal path. The tools used to control your various frequencies and overall audio signal path can be quite complex. And like I said, we're going to be diving into these in other classes. But this is an outline of what an equalizer looks like with different settings. If we had everything flat, there'd be just a flat line right here. But here there are different settings that change the signal to give it some lows and some highs and so on and so forth. Now, the most basic EQ that we're going to deal with is from this console, this very basic board. The EQ, here we have two knobs. It's, like I said, it's very basic. This one is for the high range, which is set at about 12,000 kilohertz. And you can boost 12,000 up 15 dB or minus 15 dB. And these are the minus 15 and the plus 15. For the low range, it lands at 80 hertz. Not kilohertz, but just hertz. And you can go down all the way. This one's in the middle. That one's down. And these are probably just, from the last time they were adjusted, or spin the knobs and so on. But that's how you adjust those. Now those are very rudimentary. This is a different EQ on the same console, and this one gives me 5 choices. Now this one is at 60, so if I have a very low bassy noise, I can turn it down or I can raise it up. This one is at 1200K, which was the same as this up here. So there's 1200K, and I can raise it up and down. Now the benefit to having more sliders is that it gives me more choices. This one gives me 3 more choices over these 2. So I have more versatility. A more advanced EQ, which quite often we'll have in our sound system, might have 8, 16, 32, 20, a lot more sliders. It gives you a lot more control over what you're trying to control as far as tone goes. But this one, like I said, is just built in. We'll be diving in more into EQ soon. Let's get out of the mixer and go to the amplifier. Amplifiers are what takes the small signal generated from a microphone or a playback device and converts it into a large signal that is converted back to sound waves by the speakers. You go in through the back of let's say we have a mixer here. You go in through the back of the mixer of the amplifier, and then you come out of the amplifier into speakers. And they shout at the audience. Okay? And that's what an amplifier is. These are power amplifiers. This is 6 of them. 3 of them with 6 channels. Each one has a left and a right, or an A and a B, because it doesn't really have to be left and right. So we have 2 up here, 2 more there, 2 more there. It's a stack of 3 amplifiers, each with 2 channels. Now, sending the sound out, it's very much like a megaphone. Now, the megaphone in this example is not so much an amplification device, but rather a focused directional control of the sound waves device. In other words, if you cup your hands together like this, watch what's going to happen with this microphone here. I'm going to cup my hands together, and it's going to appear to get a little bit louder because all those sound waves are then focused forward. And that's what a megaphone does. It focuses your voice. So check this out. Testing 1 2 3. Testing 1 2 3. It got noticeably less loud because I was pointing the sound waves away from this microphone. Same thing goes when you're pointing your speakers at your audience. Now in a future class, we are going to cover layouts and how to cover your complete audience depending on what kind of microphones you have. And each speaker has a certain directionality to it that we're going to read from the speaker dispersion charts. For now, this microphone is pointed at whatever angle this seems to be. Now, speakers. Speakers are much like megaphones and your vocal cords working together. The diaphragm of the speaker resonates back and forth and pushes air. It pushes the air forward and or back. That's what creates a sound wave, because that wave goes front and back and forth, back and forth, back and forth. The shape of the cone resembles a megaphone in that it gives some directionality. And some speakers are extremely directional because of the way that the rest of the box is built, and some can be heard from just about anywhere. The lower tones are heard anywhere. for the most part, and the higher tones are much more directional. I don't know if you have a stereo system at home, like a 5.1 for your sound system for your TV or whatnot, but that 0.1 is the subwoofer that sits in the corner, but you can hear it everywhere. Whereas the other speakers are more directional, and you point them to where you're sitting. And hopefully you point them at your seat so you get the best sounding experience. Now, this microphone here, this speaker here is probably, a lower range because it's got a big diaphragm, and it pushes the air out. Now, inside this box, there may be cones shaped like, cones shaped like megaphones, or, the case of the box can be shaped like a megaphone and direct the sound in one direction. That's the basics of this speaker. Let's talk about how to power them. Now, the difference between these two speakers, other than their cabinet style, is not evident at first glance. The one on the left is called a passive or non-powered speaker, and this requires an external amplifier. The one on the right is referred to as a powered speaker, as there is an amplifier built in. How do we tell? Let's look at the back panels. So this one here for the unpowered one has two ports, two inlets for connectors. Now these happen to be special connectors for speakers, and various different speakers might have different connectors, so yours may look different. But you'll notice it just has these two ports. Some of them will just have one port. This panel over here on the right, however, has a port for a power cord, and it has control lines. This we see that will have two microphone ins. It's sort of like a mini mixer. Let's take a closer look at that. So here we have a microphone, channel 1, and actually this is both a microphone port and an instrument or line level port. This will accept an XLR cable, or it'll accept a 1/4 inch cable right there in the center. Okay, so the XLR cable has the 3 dots, or the 3 pins. So there's 1, 2, 3. Just like here, 3 pins, XLR. And the 1/4 inch one just has, you just stick it straight in. Here we have a gain control, and you'll see that this one's pointed a little bit more off to the line area, right, for line level. There's also mic level over here. This one's pointed more towards mic level. So line level, it has more power, so it needs less gain. Mic level has less power, so it needs more gain. Again, gain is the sensitivity of how much it's going to allow to suck in from the microphone. And then we have this main control over here. Here we have an infinity mark. Now infinity means full resistance, which means nothing comes through. It stops completely. Infinity resistance. Maximum means it's allowing the maximum power to go through. And lest you think this knob controls this output, it actually doesn't. It does, but it also controls these two outputs over here. So this goes out of here through the main, then out the front of the speaker. So you need to make sure that that's turned up when you're doing that. There are some modes that can be used in the speaker. Your mileage may vary depending on the microphone, on the speaker that you have. These happen to be Mackie from a choir that I was able to take these pictures from. Powered speakers come in handy for a lot of school functions. You can walk into a room with a speaker and a microphone and a cable and be powered up in no time because you just plug it into the wall. Now, with that said, we do need to have some caution though, because on the back of this, we'll notice that it has a model. It's called the Thump 15A. Now the 15A stands for amps. It tells us what kind of circuit we can plug it into in the wall. Here it says 1300 watts. So if it says 1300 watt loudspeaker, and it's got 15A right in the name, we need to plug it into 15 amp circuits into your classroom or other venue power. It also means that if you plug 2 of them in, you may blow the circuit or the circuit breaker. So you've got to be cautious about that. We don't want to be blowing our circuit breakers, but if you have 2 of these and you drive them to some degree of loudness, as these get louder, they take more power. So if it's very low, you probably won't have a problem. But if you get loud, it may draw enough current out of the wall that it's going to trip the circuit breaker. So you need to check out the circuits in your classroom or other venue to make sure that you're not going to run into that trouble. So again, we go back to our purpose. We're going to transport the audience away from the theater in mind and spirit. I have a list of questions that I ask myself when I'm designing a show. And though I hesitate to read slides during my presentations, these are the questions that I like to ask myself and or my production team when we're discussing how a show is going to look and sound. Because they need to look the same as they sound, usually. Otherwise we'll have construction noises over huts, over water. Where does the event take place? What would we like it to sound like? When does the show take place? Now, when is important because it could be, if this is old-timey movie time, you have a totally different set of speakers that you may want to use. Or let's say you're doing a scene that's in an old-time movie theater. The speakers there are going to be different than the speakers we have in today's movie theaters. Or if they're listening to radio, for example, Anything Goes. That starts with a shot on the radio, and it's got the orchestra playing, and add a little bit of scratchiness to it because they're supposedly playing a record from the radio station, and then you segue or crossfade into the grand orchestra. So when does it take place? How do you want to cover that? What sounds would we hear if we were in that time and place? Same thing. If you're designing an event like this session, what would it sound like? Remember when we were quiet and we listened to the room around us? Well, that's what it would sound like. Are you watching this class from a coffee shop with earbuds? Well, what does the rest of the coffee shop sound like? I hope they have good Wi-Fi. That's the kind of thing that I'm talking about. Now, I have some favorite books that I like to use, and I'm going to show you an old illustration from Dina Kaye's book, which is Sound and Music for the Theater, which the 3rd edition here has now has a co-author, James Lebrecht, and this is the illustration from the old 1st or 2nd edition. I don't remember which one. And we see here that they use a cassette deck. We would use a stereo, or not a stereo, but we would use a computer. They use a home stereo amplifier. I guess this was for off-Broadway size theaters. It's very possible. And then we have left and right out, okay, to a speaker switcher, maybe an AB switch, but maybe a splitter. And this speaker could be inside the TV that's on stage, and so on. If we look at their larger layout, it's a little bit more modern. And now we're looking at a theater layout where we have a mixer, we have hard disks, again computers, microphones, we have a reverberation unit using the effects in and out. We've got a bunch of speakers from different outputs to different places on stage, and subwoofers, and then the proscenium speakers right there. So it's another set of layouts. I'm going to pause this and we're going to switch gears. I'm going to show you some of the other books that I like to use when I'm teaching sound design and or sound technology, the physics of sound and such.